Welcome grade 8. Today I'm just going to do a brief demonstration to help you understand how a titration works. So hopefully when you get to that part of the textbook you won't have too much difficulty understanding the terms and what's happening during a titration. So in a titration we have a number of different pieces of glassware. We have a burette, and inside the burette we put our standard solution. Now the standard solution is the solution in which you know its concentration accurately. So in this acid-base titration, the standard solution that I'm using today is sodium hydroxide, and sodium hydroxide has a concentration of 0.142 moles per cubic decimeter. Now we're going to use that known concentration of our standard solution to try to determine what the concentration of the hydrochloric acid is. And so what we need to do to be able to do that is we need to add very accurately a known volume of hydrochloric acid to our conical flask. And we do that by using a pipette. This is a volumetric pipette and it only has one mark on it, and that mark basically is 25 cubic centimeters or 0.025 cubic decimeters. So if you fill up this pipette to that mark, that's how much hydrochloric acid you have. Now to use a pipette, you need a pipette filler. And you'll get a lot of practice with these. Very carefully you put the end of the pipette filler on to your pipette, and then you can use that to suck up your hydrochloric acid. Whenever you do a titration, you want to be very careful that the level of the hydrochloric acid is on the mark that you are trying to get. You really have to put a bit of effort in to be careful, and the reason simply for that is if you don't do that, then you're not really going to get an accurate result. Okay, so that volume of hydrochloric acid then goes into your conical flask. We just let it run out using gravity by taking the pipette filler off the top of the pipette. Okay, the last thing that we need to do before we start to do the titration is we need to add a little bit of indicator. In this case I'm using phenolphthalein. Phenolphthalein is colourless in acid solution, but when the solution starts to become alkali, it will turn pink. And as soon as it turns pink, I know that I've added exactly the right volume of sodium hydroxide to totally neutralise the acid in my flask. And by knowing that volume that I've added, I can then determine what the concentration of my acid was. In terms of adding the indicator, I just need a few drops. Around about 2 or 3 is fine. Add them to my flask. As you can see, when I do that, there's no colour, it's still colourless. Okay. If you look at the board at this moment, you can see that I've already done 2 titrations. That is, I've already done this titration 2 times before. I've seen on the first time that I added about 19.9 cubic centimeters or 0.01990 cubic decimeters of my sodium hydroxide to neutralize my acid. In the second time I added about 19.95 cubic centimeters to neutralize my hydrochloric acid. So I'm just going to do it one more time, and then I'm going to use the 3 results to get an average, and I'll use that average value to work out the concentration of my hydrochloric acid. Now, because I know that I have to add about 19 mils before I reach the end point, that is the point in which the indicator turns pink, then I can very quickly add the first 15, 16, 17 mils, and then once I get a little bit closer, I'll slow down. So I've added 17 mils now. If you look carefully, you can see that as I add drop by drop, it goes pink for a little while, but it goes back to being colourless. Okay? As I get closer and closer to the end point, that pink colour will stay a bit longer before it turns colourless. And then finally, it won't turn back colourless again. So I'm very close to the end point. And there it is, it's just turned pink. And so I have neutralized the acid in this flask by adding sodium hydroxide from this burette. The amount of sodium hydroxide that I added, according to this, is 20.25. So let's have a look at that. 0.020, 0.2000. And when I subtract this value from this value, 0.01990. Okay, so I have 3 volumes of sodium hydroxide that were added for 3 different titrations. And then if I take the average, which in this case I'll just do in my head very quickly, is about 0.01992 rounded off, I should be able to now work out the concentration of my hydrochloric acid. So I'll go through the calculations for doing that now. So it takes 3 steps. We know the concentration of our sodium hydroxide, and now we know the volume of sodium hydroxide used to neutralize our hydrochloric acid. And from our formula, the concentration equals the number of moles divided by the volume. So I can work out the number of moles of sodium hydroxide that was added to our hydrochloric acid. So the number of moles is just equal to the concentration, 0.142, times the volume, 0.01992. Now when I do that, get out my trusty phone. I'm not allowed to use phones in schools, but this is a calculator now. 0.142 times 0.01992 equals, I have 0.00283 moles of sodium hydroxide. Now what I need to do now is use this value to work out the number of moles of hydrochloric acid that I had in the flask. And the way I do that is I look at the balanced chemical equation. In this equation, 1 sodium hydroxide reacts with 1 hydrochloric acid. I don't have 1 mole of sodium hydroxide, I have 0.00283 moles of sodium hydroxide, so I must have the same amount of hydrochloric acid. So the number of moles of hydrochloric acid equals 0.00283 moles as well. So now I have enough information to be able to work out the concentration of my hydrochloric acid. Because the volume of hydrochloric acid in the flask was 0.025 cubic decimeters, the number of moles of hydrochloric acid in the flask is 0.00283. So therefore the concentration of my hydrochloric acid is just equal to 0.00283 divided by the volume, quickly do that, and I have 0.113 moles per cubic decimeter of hydrochloric acid, and that is the answer. So just going through this one more time very quickly. The purpose of doing a titration is so that we can determine the concentration of one solution by reacting it with another solution of known concentration. In this case, we've just done an acid-base titration. We knew the concentration of the sodium hydroxide, that is the standard solution. We could use the volume added to neutralize the acid, and by doing that we could work out the concentration of our acid. Thank you very much. I hope that will help you to understand some of your work that you'll be doing.